how do we graph quadratics from their general, which is sometimes called standard? The book that we use actually calls it standard form, which is y equals ax squared plus bx plus c. All right, so let's break it down a little bit. The first thing that I want to focus on is the a. All right, now this a is actually the same a from y equals a times x minus h squared plus k. Okay, so this a tells me whether or not this thing is reflected, right? So if a is positive, so if a is greater than 0, our parabolas will open up like this. Likewise, if a is negative, if a is less than 0, it'll open down. Right, so you'll have a parabola that looks like this. Because it's that same a right here, this also tells us whether or not we have a vertical stretch or compression. And the way that we know if it's a stretch or compression, again, is because it's that same a from a times x minus h squared plus k. If a is bigger than 1, like where the absolute value of a is bigger than 1, then we have a vertical stretch. If it's between 0 and 1, we have a compression. Now the next letter that I'd like to focus on is C. Okay, so C is the y-intercept at the point 0, C. Now you have to be very careful because a lot of people confuse this k and they start thinking that k is the y-intercept. But if you have it in this form, this x minus h squared over here, k is not the y-intercept. But if we're in this form, ax squared plus bx plus c, c is always the y-intercept. All right, so in graphing quadratics, you've probably noticed that they're the same on both sides, right? So it's like it's mirrored right down this line. Okay, and this line actually has a name. It's called the axis of symmetry. So as we can see, it's a vertical line. So the equation of the axis of symmetry, since it's a vertical line, will be an x equals. Right? And the way that we find this is x equals the opposite of b over 2a. Now, on this line, we have the vertex of the parabola. All right? That's the maximum or minimum value on that parabola. In all applications, the vertex is probably the most important point on a parabola. The way that we find it, notice that this x equals opposite of b over 2a, this line x equals, this contains that same x value. So whatever this is also the x value of the vertex. So our point would be opposite of b over 2a. And then to figure out the y value, you just plug it back in to find y. So f of opposite of b over 2a. And we'll do an example of this to see what this means. Whenever we're being asked to find a maximum or minimum value, what you're really being asked is to find the y value of the vertex. All right, so let's do an example. Find the max or min of y equals negative 3x squared plus 12x minus 6. Well, the first thing I noticed is that this is a negative 3x squared, so I know that this function is going to open down. Right? So if this is my vertex, this must be a max. So I'm solving for a maximum value. All right. Let's go ahead and figure out what a, b, and c equal. A equals negative 3, b equals 12, and c equals negative 6. Well, since I'm looking for the vertex, the very first thing I'm going to do is find the x value of the vertex. The x value of the vertex comes from the opposite of b over 2a. So the opposite of b would be negative 12 over 2 times a of negative 3. So negative 12 over negative 6 equals positive 2. This is the x value of the vertex. And x equals 2 would be our axis of symmetry. All right, so what we want to do now is plug this value back into our equation to find the y value of the vertex. Okay, so now we have y is equal to negative 3 times, plug in this 2 squared plus 12 times 2 minus 6. All right, so y equals negative 3 times 4 plus 24 minus 6. This is negative 12 plus 24 is 12 minus 6. The y is equal to 6. So now let's put this into context here. We have a parabola. Let's have a graph here. We have a parabola that has some vertex at 2, 6. And we know that the y-intercept is negative 6. So, it's somewhere down here. So we know that it opens up like this. Right? And so my maximum value is just this y. So I'd say my max is y equals 6. Now, of course, this is just a super rough sketch. Now let's look at how we would actually graph this correctly. We'll start off with a simpler example where we have of the form y equals ax squared plus c. So what's missing here? There's no b value. So without a b, there's no shifting left or right. In this case, this is really nice. The y-intercept is the vertex, so we don't even have to solve for opposite of b over 2a and all that kind of stuff. I mean, let's think about it. If we did have opposite of b over 2a, well, there's no b value, right? So this would just be 0. Plug that back in for x, and you'd have just 0 plus c, right? So you have the point 0, c. We know that the y-intercept is always the point 0, c, and it's also the vertex in this case. All right, so let's actually see an example of this. Let's graph y equals negative 2x squared plus 2. All right, so since there's no b, the vertex is going to be at the y-intercept. So here's c. So the y-intercept is at 0, positive 2. All right, so this is my vertex at 0, 2. And then through the vertex, remember, is our axis of symmetry. We have to label all these things. So my axis of symmetry, remember this is a line, is x equals 0. It's very important that whenever you write out the axis of symmetry, that you do it as a line. So x equals something. All right, now to actually plot it, we remember that this negative 2 is the same a from our old parent function stuff. So this is reflected, and it's got a vertical stretch of negative 2. So we're going to use that a to find 2 more points. We know that the parent function usually goes over 1 and up 1, over 2 and up 4. Well, since this is reflected, the y values are going to be multiplied by negative 2. So instead of going over 1 and up 1, I'm going to go over 1 and down 2. Right? Or I can go over 2, and instead of going down 4, now I have to go down 8. Right? Because it was stretched by negative 2. And then this is an axis of symmetry, so I can just plot the exact same points on the other side. And now I missed it a little bit, but I have my function. Now you don't always have to find these bottom points. We really only need 3 points to find the basic shape. And another way that you can do this, I just hate suggesting it, is because this is a negative 2, you can only to the first point. It's crucial that you don't use it for more, but only to the first point you can use this negative 2 kind of as a slope to that point. But the slope changes whenever we get to the next point. So I'd rather just think about this as a vertical stretch. All right, but what if we had to graph with a b? Right? So here we have y equals negative x squared plus 4x minus 3. Step 1 is to find the axis of symmetry. So we say x equals the opposite of b over 2a. So the opposite of b would be negative 4 over 2 times, what's a? Negative 1. Negative 4 divided by negative 2 is positive 2. So x equals 2 is the axis of symmetry. All right, so the first thing I'm going to do is I'm going to plot my axis of symmetry right along the line x equals 2. All right, now I need to find the vertex. And to find the vertex, I'm just going to plug this x value right back in to solve for y. So y equals negative 2 squared plus 4 times 2 minus 3. And this gives me a y value of 1. So my vertex is at the point 2, 1. And we'll plot that point. All right, now, since we had a shift to the right, this is really nice, because now I can just plot the y-intercept. And where's our y-intercept? It's at 0c, right? So my y-intercept is going to be at the 0, negative 3. And because this is an axis of symmetry, I can just reflect this point over the axis of symmetry to right here. Okay. Now, I can also think about this. A was negative 1, so all this is a reflection. So look, I went. There is a point right here, going over 1 and down 1, and then see, whenever we went out 2, we should go down 4, which is exactly what happened. But the equation went ahead and told us that because of the y-intercept. So we can go ahead and graph the rest of this parabola. Okay, and that's how we graph quadratics from their general form.